What if I told you a free AI model beats OpenAI in coding? I tested 3 cutting-edge AI reasoning models: Deepseek R1, OpenAI's O1, and Gemini 2.0 Experimental Advanced, to see their vibes and who actually delivers. And trust me, the results are wild. By the end, you'll know which model I'll be using from now on for coding. And the winner is... Last week, the AI world went crazy. Deepseek, a startup from China, released a free open-source AI model that outperforms OpenAI's O1 on some coding benchmarks. Even more shocking, Deepseek offers an API that's 27 times cheaper than O1. And unlike with OpenAI, you don't need to spend thousands of dollars on API credits just to get started. Meanwhile, over on Chatbot Arena, where people vote on which AI model does better in real prompts, Gemini 2.0 Experimental just took the top spot from O1. Their scores are super close, but DeepSeek doesn't have many votes yet. It looks like my previous go-to model, Claude 3.5 Sonnet, got left behind. This is why I decided to design my own experiment and pick a new go-to coding model based on the vibes and results I get. Here's how I'm testing each model. First, I picked 3 scenarios that are simple but still show off coding and reasoning skills. We have a mood tracker app, a random food recipe generator, a catch the mole game. Then I created a PRD, project requirements document. The PRD describes exactly what the app should do, so the AI knows the rules of the project and it's easy to verify if the models did their job. Next, we'll ask each model to build the app in one shot. That means I give them the PRD and they give me the full code base. If the model's code doesn't run or has errors, I'll provide feedback until the app runs without errors. I'll be doing all of this in Cursor AI, a coding environment that integrates smoothly with these AI models. It allows me to save the PRD as a file in the codebase, for example as requirements.md, and use it inside the composer. We can just accept the suggestions of the AI and see if the app works. To see which model performed best, we'll score each of them based on these 4 areas. Does it work? If the app runs successfully and allows me to complete the whole user flow, that's 1 point. Second chance fixes. If it fails the first time but succeeds after my feedback, it still earns 0.5 points. Code vibes. This is 1 point if the code looks neat, organized, and easy to follow. UI vibes. Another 1 point if the final user interface feels smooth and looks good. After I test all 3 scenarios, I'll add up the points to see which model comes out on top. Let's dive deeper into the AI world. Experiment 1, Mood Tracker app. So, let's kick off with the first experiment. I want this to be a modern, polished web application, where a user can log their daily mood and see beautiful visualizations of their emotional ups and downs over time. To keep everything consistent, I've created a project requirements document. This covers our core flow. Pick a date, choose an emoji, add a note, and see your moods visualized. To make sure we compare apples to apples, we're going to test the code against the following success criteria. Clicking any date in the calendar opens a mood logging modal or dialog. Saved moods reflect as colored or icon-marked calendar entries. A stats page displays at least 2 types of charts. For example, a line chart plus a pie chart. Alright, enough talking. Let's see how the models performed. First up, Deepseek R1. After setting up the project repository, I pasted in the prompt that you can now see on the screen and hit enter. If you want to use the prompts and PRDs I used in this video, I leave the link to the resources in the description. After wrestling with a few stubborn dependencies and squashing some pesky bugs, and about 10 back and forths with the model later, we finally got our hands on a working version of the app. Let's take a look at what we've built. The UI is pretty straightforward. But the real question is, does it actually deliver on our user flow requirements? Time to break it down with our validation checklist. First up, calendar interaction. Good news, we can click dates to log our moods. Bad news, you can't see what you're clicking until after you've clicked it, and we're stuck in a single month view with no way to scroll. That's going to cost us some points, 0.5 out of 1. Next, color coding. While the dates do update with emojis, we're missing that visual color feedback that makes patterns instantly recognizable. The emojis are doing some work here, but not enough for a full score. We'll give it 0.25 out of 1. On to the next requirement, chart page. Now, this part is pretty solid. We can track our scores and see mood distributions, plus the weekly trend views are a nice touch. However, there's no toggle between weekly and monthly views, and the weeks could be better organized. That gives us 0.75 out of 1. And the last requirement, data persistence. This one's a win. You leave the app, come back later, and all your mood entries are still there. A perfect score of 1 out of 1. When we add it all up, we get a total of 2.5 out of 4, which translates to 62.5%. Not bad for a first iteration, but there's definitely room to refine and improve for version 2. Alright, let's see if we can get the model to iterate on what's missing. Here's what I aimed to fix this time around. Calendar interaction. Previously, you couldn't see the dates until you clicked on them. Plus, you were stuck with just the current month. No way to switch between months. Color coding the calendar tiles. The emoji picker was letting you select any emoji, even ones that aren't linked to a mood score. This was confusing. Also, the calendar tiles weren't reflecting any color changes based on the mood you picked. Chart page. The chart page still didn't allow toggling between weekly and monthly views, and the charts themselves weren't colored to reflect the mood scores. I headed back to Cursor to see if Deepseek could tackle these issues. Unfortunately, Deepseek ran into some trouble and ended up crashing the codebase when trying to apply these changes. Worse yet, it wasn't able to fix everything on its own, and we had to switch over to using Sonnet 3.5. With a little clue from Sonnet, I managed to get things up and running again. Keeping that in mind, let's take a look at the results. Calendar interaction. Now you can actually see the dates right away, which is a big improvement. Plus, switching between months is now possible. Color coding. The calendar tiles update with color once you pick an emoji. However, the color assignments aren't perfect yet. Average moods are showing up as green, while excellent moods still appear gray. On a positive note, the emoji picker now limits you to the approved mood icons, though the selection panel itself is a bit on the dark side. Chart page. The chart page has a new feature. You can now toggle between weekly and monthly views. That said, the charts still haven't been updated with the correct mood colors, so there's room for improvement there. Overall, the changes are a step in the right direction, but not all the issues have been resolved yet. I'm giving it a score of 0.25 out of 0.5. Now, let's talk about the code vibes, essentially how well the model structured the code. Overall, the model maintained the file structure as outlined in the PRD. The only oddity was with the mood calendar handling, which appears to be a side effect of the bugs Deepseek was trying to resolve. Speaking of bugs, this is where Deepseek really struggled. It often went in circles trying to fix issues, and one particular bug even had to be solved with a little help from Claude Sonnet. Because of these hiccups, I can't give it a full score for the code vibes. I'll rate it 0.75 out of 1. Now, the final category, UI vibes. Apart from the ugly color of the background, the final UI looks pretty neat. We've got an attractive calendar with well-designed tiles and a clean navbar that lets you switch effortlessly between the calendar and statistics views. That said, there's still room for improvement in the mood picker and the statistics views. Because of these minor issues, I'm giving the model a score of 0.75 out of 1 for UI vibes. And that wraps it up for DeepSeek in Task 1. Overall, the model scored 2.375 out of 3.5 in total. Next up, we have Gemini 2.0 Experimental. Let's see how it performed. After a bit of debugging the dependencies and sorting out some minor issues, which took about 15 additional calls to the model, I finally received the first version of the app that ran successfully. But here's where the issues begin. Calendar interaction. I can see the calendar rendered, but there's no interactivity whatsoever. Because of that, I'm giving this aspect only 0.1 out of 1. Color coding. There's no functionality to set any emojis at all, so this section scores a 0 out of 1. Chart page. The chart page does appear, but it only shows one empty chart, and there's no way to navigate back to the starting page. There's no navbar. That earns this feature 0.1 out of 1. Data persistence. While it seems like data persistence is implemented, I wasn't able to properly test it. Therefore, I'm giving it 0.5 out of 1. Adding it all up, we get a total score of 0.7 out of 4, which scales down to 0.175. While Gemini made it to the running stage, it definitely has a lot of room for improvement. Let's dive into the second iteration with Gemini, where we aimed to improve the user flow after implementing a mediocre first version. After about 10 back and forth messages with minimal guidance, here's what we got. Calendar interaction. Now, you can click on a date and choose an emoji, a definite step forward in interactivity. Color coding. The color coding still isn't fully implemented, so that part remains a work in progress. Chart page. On the bright side, I can now move between the home and stats pages. However, after picking moods on the home page, there's still no chart to visualize the data on the stats page. Because of these mixed results, I'm giving the model half of the available points for this iteration, 0.25 out of 0.5. Let's talk about the code vibes. Overall, the model followed the intended code structure very closely. This suggests that with a bit more refined instruction, it could nail the complete app even on the first go. The code itself is clean and modular. There's really nothing to complain about here. For that, I'm giving the model 1 out of 1. Now, let's move on to the code vibes for this iteration. The UI is very basic and minimalistic. In the first try, the model even forgot to implement essential components like the navbar. Because of that oversight, I can't give it a higher score than what we saw with Deepseek R1. So, for the UI vibes, I'm assigning a score of 0.5 out of 1. That wraps up our review for this iteration. Overall, the model scored 1.925 out of 3.5. Let's jump into the third model, OpenAI's O1. Just like with the other models, after around 10 rounds of debugging and fixing issues, we finally got the app up and running. Now, here's how the UI looked. At first glance, it stands out as the best among the 3 models we've tested so far. We have a clean home screen that makes it easy to navigate to either the calendar or the stats page. But the real question is, can it complete the user flow? Let's check it against our validation checklist and see how it scores. Calendar interaction. We can click on a specific date, but just like with DeepSeek, you can't scroll through different months. Only the current month is visible. What's even more problematic is that the tiles for the current month are disabled. The calendar only updates the mood entries for the previous and next months, leaving the current month gray. Because of these issues, I'm giving this section 0.5 out of 1. Color coding. The date cells do change color based on the mood score, which is great, except they only work for dates that aren't in the current month. That makes the feature pretty unusable for our primary view, so I'll score this 0.5 out of 1. Chart page. The chart page is working fine. we can see our mood trends over time, and the mood distribution is properly color-coded. However, just like with DeepSeek, we can't switch between weekly and monthly views. For that, I'm awarding 0.75 out of 1. Data persistence. Data persistence is spot on. Your entries remain intact as you navigate away and come back. That earns a perfect 1 out of 1. When we add it all up, we get 2.75 out of 4, which translates to 68.75%, a little bit better than what we saw with DeepSeek. Now, let's see if we can get the model to iterate on what's missing. Now, let's see how OpenAI's O1 handled the second iteration after going back to Cursor for improvements. After applying the changes, the UI looks noticeably different. Calendar interaction. The text is much more visible now, which really helps with readability. Plus, we can now switch between months seamlessly. Overall, a solid improvement in navigation. Color coding. The tiles are now colored, but only when the mood score is set to 3. It's definitely an improvement, though not 100% there yet. On the upside, you can now pick only from the approved emoji icons, which makes the interface cleaner and more consistent. Chart page. The chart has been refined. It no longer spreads across the entire screen, and it looks much better organized. And now, we have the functionality to switch between weekly and monthly views. Overall, this iteration is a solid step forward. I'd give the model 0.4 out of 0.5 for its ability to iterate. Had it nailed the color coding completely, it would have earned the full score. By the way, after a few fixes with Claude Sonnet, I was able to create a perfect app. But for the test, we won't account this version as that would be the third iteration of this app. Now, let's check the code vibes. The code is structured exactly as outlined in the file structure from our requirements.md. It's also impressively clean. It was easy to iterate on the last issue with the calendar to improve the app. Because of this, I'm giving it a full 1 out of 1 for code vibes. Now let's talk about the UI vibes. The app maintains a minimalistic yet pretty aesthetic design. That said, I have to mention that I actually preferred DeepSeek's calendar view over this one. Additionally, the navigation isn't fully optimized. You can't easily navigate back from the calendar or stats view to the home screen. On the flip side, the stats view is a standout. It's simple, straightforward, and it does the job perfectly. Taking all of that into account, I'm giving OpenAI's O1 a 0.75 out of 1 for UI vibes. OpenAI's O1 achieved an impressive overall score of 2.838 out of 3.5, making it the best performer among the 3 models we evaluated. Experiment 2, Random Recipe Generator. Alright, now we're diving into something a bit different. For this challenge, the AI models need to integrate with an external API, specifically the meal.db, to fetch real recipe data. Users will be able to select a meal category, and with just a single click, the app will fetch a random recipe that comes complete with detailed ingredients and step-by-step cooking instructions. And if you come across a dish that looks too good to pass up, you can easily save it to your favorites. Let's break down the key validation criteria for this challenge. API call. The app must successfully communicate with the meal.db's endpoints. Random generation. Every time the user triggers the process, they should see a new random dish from the fetched results. Filter category support. Users should be able to select from a range of meal categories. Favorites. There needs to be a dedicated /favorites page where users can view all their saved recipes. Data persistence. Even after a page refresh, the favorites list should remain intact, thanks to local storage. Let's see how the models performed. We're starting off once again with DeepSeek. This time around, DeepSeek really nailed it. The code was generated almost perfectly on the first go, and I hardly had to step in for debugging. It just goes to show how impactful a clear and detailed PRD can be when working with Cursor AI. Let's jump in and rate the app. API call. We can successfully call the MealDB's endpoints, whether we're fetching a random recipe or filtering by category. That earns us a full 1 point. Random generation. The random recipe feature works perfectly, delivering a new dish every time. That's another 1 point. Filter, category support. The app lets you filter meals by category with ease, which secures another 1 point. Favorites. We can save our favorite dishes, and while you can remove an item from the list, clicking View Details doesn't actually show the details. So, I'll give this section 0.75 out of 1. Data persistence. After a page refresh, the app still displays our favorite dishes, which is exactly what we want. Another 1 point. Altogether, Deepseek really did well this time, scoring 4.75 out of 5, which translates to a solid 95%. Great work, Deepseek. Deepseek nearly aced the first version, but there were still a few areas that needed improvement. Let's break down the updates we aimed for. Favorites details. Previously, clicking View Details on a favorite dish would just redirect us to the home page, leaving us without any details. This issue has been fixed, so that's a solid 1 point. Initial app view. When opening the app, a blank page is displayed. Fortunately, the model didn't address this at all. That's 0 points for this part. Home button in the nav bar. The home button was only appearing on the home page, which didn't make much sense. I asked for it to be removed or improved, and the model complied by removing it. Although this change is not perfect, it was done per my request, so I'll give it 1 point. Overall, this iteration scores 0.33. It's time for Code Vibes section. The model followed the code structure very well and added the meal page after it was asked to do so 1 point for the code vibes and Deepseek's creativity. Let's talk about the UI vibes. The UI is definitely functional, aside from that initial homepage issue, but it could benefit from a more polished aesthetic. However, I might not have provided enough detail to prompt the model in the right direction for that extra sparkle. On the plus side, I really like that the model included photos of the dishes and made improvements to the ingredients section in the second iteration. Taking everything into account, I'm giving the UI vibes a solid 0.75 out of 1. Let's wrap up the second task for Deepseek. When we sum it all up, we've got a total of 3.03 out of 3.5. A very impressive score for task 2 from Deepseek. Next up, we have Gemini 2.0 Experimental. Let's see how it performed. Gemini was remarkably fast. Unlike Deepseek, it can produce an entire codebase in one inference. This time, no debugging was needed at all. The app ran immediately after the first iteration of code generation. Let's rate Gemini based on our validation checklist. API call. We can successfully call the MealDB's endpoints, whether it's fetching a random recipe or filtering by category. That's 1 point. Random generation. The random recipe feature works perfectly every time. Another 1 point. Filter, category support. The app allows you to filter meals by category seamlessly, which earns it 1 point. Favorites. You can save your favorite dishes without any issues. However, there's no View Details button implemented, so while you can remove an item from the list, you can't actually see the details. That nets us 0.75 out of 1. Data persistence. After a page refresh, the app still displays the favorite dishes, which is exactly what we want. Another 1 point. Summing it all up, we once again get 95% for the user flow. Let's now run through Gemini's second iteration. Layout. The app still spreads across the entire screen on wide displays. We aimed for a centered layout, and while the model tried, it's not fully fixed, so that's 0.5 out of 1. Favorites page. Now, when you click on a saved dish, The food card expands to show details like ingredients and instructions. Not perfect, but it works. 1 out of 1. Overall visuals. The app remains quite basic. The model attempted to enhance the UI, but the changes actually made it look worse. So 0.5 out of 1. That brings us to a total of 3 out of 4, which scales to 0.375 points for code iteration. Time to check the code vibes. Gemini followed the code structure very well. However, it wasn't as creative as Deepseek, which came up with the idea of creating additional page for presenting the meals, so I will give it 0.9. Let's talk about the UI vibes. The UI is functional, but some parts are ugly. For example, the expanded meal card could use some work. I probably didn't specify enough detail on how the UI should look, but hey, we'll blame the model because we can. I'm giving it 0.75 out of 1. So in total, we have 2.975, not bad at all, but a bit lower than Deepseek. Let's jump into the third model, OpenAI's O1. Let's break down the results for OpenAI's O1 in Task 2. API call. We can successfully call the MealDB's endpoints. That's a solid 1 point. Random generation. The random recipe feature works perfectly every time. Another 1 point. Filter, category support. We can filter the meals by category, even though the filter tab isn't the most visually appealing. Still, that functionality earns 1 point. Favorites page. We can save our favorite dishes. While we can't view the details of a dish, we can remove it from the list. That nets us 0.75 out of 1. Data persistence. After refreshing the page, the app still displays our favorite dishes. Another 1 point. Overall, the score comes out just like the other models. It seems that these reasoning models have made this app a breeze to build. Let's check out the improvements. Widescreen layout. The app now has a responsive layout that centers the content on wider screens. That earns 1 point. Favorites. The dish details are now accessible through a View Details button. This is a good fix, so we give it 1 point. Category filtering. The filter card now displays more aesthetically, and the filter tab automatically closes after a selection while showing the current category. That also gets 1 point. That means O1 has achieved the maximum score for this category, and we're adding 0.5 points to the overall tally. Next, Code Vibes section. Just like with the previous models, the code looks clean and modular. I like the fact that we also created a home folder just like specified in the folder structure. However, I will give O1 0.9 because I want to feature Deepseek's creativity coming up with the idea of creating the meal page. Let's dive into the UI vibes for O1. The UI is functional overall, but there's one element I'm not too fond of: the expanded meal card, which stretches across the entire row of meals. Despite that, I actually like this UI the most. With that in mind, I'll give it 0.8 out of 1. That brings the overall score to 3.15, with O1 coming out on top once again, though the difference is minimal. Experiment 3, Catch the Mole game. Now it's time for some game action. We're about to see if these models can code a fast-paced, fun game where moles pop up at random, and we have to whack them as quickly as possible. In this challenge, the AI must tackle animations, sound effects, and a game loop that handles real-time user interactions. This is something totally different compared to our previous tests involving forms and data fetching. Let's jump in and watch the models bring this game to life. First up, Deepseek R1. This time, Deepseek once again generated the code almost perfectly on the first try. I hardly had to do any debugging, apart for reprompting it to keep generating the codebase. Let's see the result. Random mole spawn. The moles, represented as circles, appear on a grid. It's not exactly what I had in mind, but it fulfills the requirement. That earns 1 out of 1. Scoring and difficulty. The score increases when you tap a mole, so that part is spot on. However, the difficulty increase isn't clearly visible. After chatting with Deepseek, I learned it's implemented, but I'm still holding back a bit on full marks. I'll give this section 0.75 out of 1. Audio playback. The bonk sound plays right after hitting a mole, which is exactly what we need. 1 out of 1. Animations. There's a subtle transition animation, but once you hit a mole, it just disappears without any extra flair. That's only 0.5 out of 1. Game over state. The game ends after 60 seconds as specified. However, the end screen is a bit messy, and the play again button is hard to hit. This gets 0.75 out of 1. Adding it all up, we have a total score of 4 out of 5, which comes out to 80%. Let's now see the iteration results. Game over screen. The model attempted to fix the overlapping issue by adding an extra button and repositioning the text. It improved functionality a bit, but the main issue wasn't fully resolved, so that gets 0.25 out of 1. Dynamic difficulty scaling. After reaching scores of 15 and 30, multiple moles now appear on the screen. This deserves a full 1 point. Mole visual design. The circle has been replaced with a proper mole image, and a popping up animation has been added. However, the moles aren't perfectly centered, so I'll give this 0.75 out of 1. Difficulty level indicator. Unfortunately, there's still no visible difficulty level indicator on the screen, so that's 0 points. High score celebration. The confetti animation works as intended. 1 point for that. That brings us to a total of 3 out of 5 points, which scales to 0.3 points. Let's now check the code vibes for Deepseek. As you can see from the slide, the model followed most of the file structure outlined in the requirements. It did miss a few elements, like the navbar and score display components, and the routing to the main game wasn't fully addressed. However, the most critical aspect, the game design and logic, has been implemented very well. For that, I'm giving it 0.8 out of 1 for code vibes. Let's talk about the UI vibes. Overall, I really enjoy the experience. It's definitely usable and playable. On the downside, the game feels a bit too easy. The progression to higher levels is a bit slow. Also, while the mole animation isn't perfect, it's good enough for a first iteration and can be improved later. On the upside, I love that the game incentivizes you to keep playing with high score challenges and celebration features. There's a real dopamine boost when you beat your high score. For all these reasons, I'm giving the UI vibes a solid 0.85 out of 1. So the overall score for the third task is 2.75. Nice job by Deepseek. Next up, we have Gemini 2.0 Experimental. Let's see how it performed. Random mole spawn. Here, the moles are implemented as circles that jump up the grid. This isn't quite what I expected. We should be seeing a mole appear in a hole, not a hole that changes its position. Because of that logical misconception, I'll give this 0.25 out of 1. Scoring and difficulty. Both scoring and difficulty scaling are implemented well. The difficulty increases gradually, making it a bit challenging to hit the circle in time. This part earns a full 1 out of 1. Audio playback. The audio is working perfectly. When you hit a mole, the bonk sound plays as intended. That's 1 out of 1. Animations. The only animation is the jumping circle, which shows that the model did approach the problem. However, when the circle jumps, it overlaps with the row above, which can be confusing. For this, I'll give 0.4 out of 1. Game over state. The game ends once you reach 30 points. Unfortunately, there's no built-in way to restart the game aside from refreshing the page, so that scores 0.5 out of 1. So in total, we have 3.15 out of 5, which translates to 63%. Alright, let's review the second iteration for Gemini. Restart functionality. The game now includes a clear Play Again button on the Game Over screen, allowing players to restart the game seamlessly. That's a full 1 out of 1. Mole overlap issue. The problem of the mole's red circle overlapping with other grid elements hasn't been addressed. This part scores 0 out of 1. Mole image. The model has replaced the simple red circle with an actual mole image. That earns 1 out of 1. High score tracking. The game still doesn't track or display the best time to reach 30 points, so this feature scores 0 out of 1. Difficulty level display. The current difficulty level is now clearly shown on the screen, which is great. That gets 1 out of 1. Adding it all up, we end up with a total of 3 out of 5 points, which translates to 0.3 points for this iteration. It's time to check out the code vibes of Gemini. The code structure looks good and clean. 4 components have been implemented. Score display and game over screen are additional components compared with Deepseek. The game logic also looks clean and easy to change. So overall, that's 0.9 for code vibes. Let's go through the UI vibes. The experience of playing the game is alright, the game is enjoyable. From the cons, the moles are visible all the time, compared to appearing from the holes as Deepseek did. Also, the game has no challenge as it just ends after reaching 30 points. From the pros, I like the animation of the jumping mole and the difficulty notification. Overall, the gameplay is less developed than the Deepseek's, so I can give Gemini 0.75 for this. So the overall score for the third task is 2.58 out of 3.5. Let's jump into the third model, OpenAI's O1. Alright, let's take a look at how O1 performed in task 3. This one was a bit of a disaster. Random mole spawn. There's virtually no randomness here. Instead of moles, we're just seeing letters M jumping vertically through the screen. That barely earns a 0.05 out of 1. Scoring and difficulty. While scoring and difficulty are implemented, it's impossible to reach higher difficulty levels since you're just bombarded with these letters. This part only scores 0.5 out of 1. Audio playback. On a brighter note, the audio playback works perfectly, so that's 1 out of 1. Animations. The jumping M is technically an animation, but it's so ugly that I can only give it 0.1 game over status. You can manually end the game and restart it, but the automatic game over after 30 seconds doesn't work as intended. This scores 0.5 out of 1. Altogether, we end up with 2.15 out of 5, which translates to about 43%. O1 really missed the mark on this task compared to Deepseek and Gemini. Now, let's see if we can fix the most important issues in this iteration. We're focusing on improving the layout, ensuring a proper game board, and enhancing the overall gameplay experience. Let's see the results. Centered layout and visual hierarchy. Unfortunately, the model failed to properly center the game, so this scores 0 out of 1. Game board. The game board is now implemented and looks much better than before. This earns 1 out of 1. Mole image. The model successfully replaced the placeholder with an actual mole image, so that's another 1 out of 1. Spawn hit animations. While the animations are in place, they're a visual disaster. Only 0.5 out of 1 is awarded here. Gameplay centering. The attempt to center the gameplay shows some progress, but the entire page remains left aligned, resulting in 0.5 out of 1. In total, that brings us to 3 out of 5 points, which scales to 0.3 out of 0.5. Let's now dive into the code vibes section. The overall code structure actually looks good, and it's clear that with some refinement, we could make this game usable. On the downside, the model tried to write its own badge and button UI components instead of using the ShadCN components as specified in the requirements. The biggest issues lie in the layout and the overly complex game logic, taking 150 lines compared to Deepseek's 20. Overall, the code generated by OpenAI doesn't look bad. That's why I'll give it an 8 out of 10 for code vibes. Last but not least, UI vibes. This is where the disaster happened. The game isn't playable because the moles start appearing way too fast, likely due to broken and overly complicated game logic. On the plus side, there's a clear section in the code where we can address this issue, so it shouldn't be too hard to fix. The other major issue is the ugly interface. There's a noticeable lack of proper UI components, like buttons, which really hurts the overall experience. For these reasons, I can only give the UI vibes a 0.2 out of 1. Summing up everything for this iteration, we end up with a total of 1.73, which is the worst score out of all our experiments. All of the experiments are complete. It's time to sum up all 3 experiments and see which model truly came out on top. After collecting the points in each experiment, I summed everything and converted it into a percentage score. And now the results are in. Third place, Gemini 2.0 Experimental Advanced with 71.24%. Second place, OpenAI O1 with 73.50%. First place, Deepseek takes the crown with 77.66%. Deepseek provided the most stable performance across all of the tasks. That's why it comes out on top in this challenge. If you'd like to see the exact prompts I used for these projects and get a closer look at each model's pros and cons, check out the link in the description. Thanks for watching, and I'll see you next time.